Switch case statement. Introduction. Hello and welcome to this video. Today we are going to learn one of the essential control statements in the C programming language, the switch case statement. If you've ever had to check a variable against several possible values, then switch case is going to make your code much cleaner and easier to read. What is switch case? The switch case is a multi-way decision-making statement. It allows a variable to be tested for equality against a list of values called cases. It's a good alternative to writing multiple if-else statements when you're dealing with discrete values. Syntax of switch case in C. Number 1, the switch checks the value of expression into the parentheses. Number 2, it jumps to the case that matches the value of constant 1 or constant 2 and so on. Number 3, if no case matches the default block, run. Number 4, break is used to stop flow and prevent falling through to the next case. Important notes and common mistakes. Number 1, switch only works with integer type, int, char, enum, no float, double, or string. Number 2, each case must be a constant, no variables or expressions allowed. Number 3, always remember to use break, otherwise it will fall through to the next case. Number 4, the default case is optional but recommended as a fallback. Comparison between switch case and if-else in C. Number 1, best use case. The switch case statement is best used when you need to compare a single variable against multiple constant values. It provides a cleaner alternative to writing long chain of if-else blocks. On the other hand, the if-else structure is more suitable for complex conditions such as comparisons involving ranges, inequalities, or logical operations. Number 2, data types allowed. The switch case statement supports only certain types, specifically integer types, characters or char, and enumerations or enum. It does not work with floating point numbers, strings, or Boolean expressions. In contrast, if-else supports any valid expression that evaluates to true or false, including float, double, and logical combinations. Number 3, all true behavior. In switch case, if you omit the break statement at the end of a case block, the program will continue executing the next case, a behavior known as a fall through. With if-else, only one block will execute, the first one whose condition evaluates to true. There is no fall through. Number 4, readability. When you're checking a variable against several fixed discrete values, switch case is generally more readable and structured. However, when your logic involves ranges or compound conditions, if-else is easier to use and more expressive. Conclusion: use switch case when you have a single variable and wanna compare it to many discrete constant values. Use if else when your conditions involve ranges, inequalities, or logical expression. That's it for today's lesson on switch case in C. It's a powerful tool to simplify your decision making code. In the next session, we'll try to create more practical example using switch in a 3 by 3 matrix keyboard. Don't forget to like, subscribe, and let me know in the comments if you have any question. Let's start by opening the Eclipse IDE and creating a new project. In this exercise, we are going to simulate a 3 by 3 matrix keypad. Inside the main function, we define two 32-bit integer variables named row and col, which represent the selected row and column. We also declare a 8-bit char variable called key, which will store the number of key that has been pressed. First, we use the printf function to display prompts asking the user to enter the row and column numbers. Then, using a scanf, we read those values from the keyboard and sort them into the row and col. Next, we use a switch statement to check the value of a row. We place the row variable inside the parentheses of the switch and define three case blocks for 0, 1, and 2. If row equals 0, the code in case 0 run. If it's 1, case 1 runs. And if it's 2, case 2 runs. Inside each case, we use if-else statements to evaluate the column number. For example, if row is 0, and col is 1, that means the key in the first row and second column has been pressed, which corresponds to the number 2. But if the column number is not 0, 1, or 2, then the pressed key is considered invalid, and we assign ASCII code for the question mark to the key variable. Each case block ends with a break statement to exit the switch structure. We follow the same pattern for row 1, where the key 4, 5, and 6 are placed. If the row value is not 0, 1, or 2, the default case runs, indicating an invalid row input. In that case, again, we assign question mark to the key. After switch block, we check the value of key using a simple if-else statement. If it's not a question mark, then we know the key is valid and we print its value to the output. Otherwise, we consider the input is invalid. Now we build and debug the program. Now we build and debug the program. We place a breakpoint at line 52 and run the code. Now we build and debug the program. We place a breakpoint at line 52 and run the code. It prompts us to enter the row and column. It prompts us to enter the row and column. We enter 0 for both and the output shows the value 1. We run it again, this time with row 2 and column 1, and the key becomes 8. On microcontrollers, we usually place the entire application inside a while loop. We'll do the same here. After defining the variables, they wrap all program logic inside a while loop and run it again. As expected, the program now runs in an infinite loop. As long as the system is on, it continuously executes the instructions. Once the key value is printed, it immediately waits for the next row and column input. This loop continuously This loop continues endlessly unless the system is powered off or reset. This is exactly how most programs run on microcontrollers. Our next video will be about for loop, a very useful statement in C programming, especially for microcontroller applications. Remember, one oil well beats 10 water wells. Explore deeply, treasures await.